Here's integrated 3.9-21. It says, Antonio's friend Jessica was also on the screamer when it broke. Her seat was 65 feet above the ground. What was her seat's angle of rotation? The angle of rotation. Is there more than one possibility? So 65 feet. So all you guys learned in class was that there's this, not a Ferris wheel, a roller coaster ride called the Screamer. And you guys studied this. And here's where you load, right on the ground where my finger's pointing. And then the seat goes here, and then the next, there's like lots of seats, right? Then the next people get on. And then it stops here, and then the next people get on. And it stops here, and the next people get on. And there's angles of rotation. This is 15. That would be 30. Well, let's look and see. And then we found out that you can tell how high they are off the ground. At first, we just did it with measuring. So, like, let's 15, 30, 45. Let's see what looks like it's about 65 feet off the ground. Well, I mean, this thing, let's get 70. So we remember that this little paper thing is a model, and that it's the radius of this is 1, but the radius of the real Screamer is 100. Okay, so 65 feet could be, I don't know, there's like 60 and 70, so 65 feet could be somewhere. It's not going to be probably an exact value. It's in here somewhere. And how many degrees do we think that is? That could be like 15, 30, that's about, this is about 45 degrees-ish. But then it also says her seat was 65 feet above the ground. What was her seat's angle of rotation? Is there more than one possibility? Well, and this thing's not perfect either. We'll find out that when I do the calculation, I'm probably off by quite a bit. But 15, 30. So if it was anywhere near 45 degrees, this would also be the same height over here. That's more like 60. So, well, I don't know. It's kind of hard to measure it, right? Maybe it's a little less than 45. So there's two places, though. Okay? So, and then we found out, we just kind of like did some studying, and we actually graphed a whole bunch of ordered pairs on this thing, and it ended up looking exactly like, you might not know this yet, it kind of looks like this. And this turns out to be the sine function. And also, maybe you don't need that for this problem, but another thing that you guys learned was that when you draw a triangle, if the hypotenuse is 1, isn't sine opposite over hypotenuse, like your trig ratio? So if I want this height right here, right there, isn't that the opposite side? And isn't the hypotenuse 1? So it turns out that we can find the height on this unit circle, which they introduced as the Screamer ride. We can find out the heights, how far you are above or below the ground from your seat, by using the sine ratio. So if I want this angle, I can just say sine of 45. Or sine, or actually here. So let's do this with math. Let's do this without using the paper measuring tool. So let's just say, let's just draw a triangle. This triangle, I mean, it is kind of like our little measuring tool, right? I'm drawing a triangle. This is supposed to be like the middle part right here at the origin. And they're telling me that this person is 65 feet above the ground. Okay, so, and we know if it's the Screamer ride, we know this is 100. So I just want this angle. And I can call it A if you want. Let's just call it A. So I'm going to say that sine of A equals opposite over hypotenuse. And then I'm going to get A by itself because they want the angle. So I'm going to inverse sine both sides. And I'll show all my work. Okay, the inverse sine cancels out sine, and I end up with A equals the inverse sine of 65 over 100. So then I just ask my calculator what that is. So my calculator, I can push shift sine, and then I can push 65 over 100 divided by 100. And so I was off a little bit when I was doing my measuring, but it's about 40.54 degrees. Ish. Okay? But we noticed that in this problem that there's more than one place where she could get stuck in her seat and still be that high off the ground. She could be over here. And we found out that it's not really 45. It was more like, remember, we found out it was more like 40.54. But that's not how we measure degrees. Like when the seat, we always measure our angle measure from the right-hand side, from the positive x-axis, okay? So if we travel all the way, we have to travel all the way around to here. So what that ends up being is, well, look, there's 45 degrees, there's 90 degrees, there's, I don't know, whatever 90 plus 45 is. Well, that's too hard to figure it out. There's an easier way. The easiest way to figure it out is go all the way around to 180 degrees and then back it up by 40.5. So in other words, what's 180 minus 40.5? Okay, so I'll just ask my calculator. So it's 130, don't look at the minus sign. It's 139.46-ish degrees. So we'll just say it's 139.46 degrees. I hope any of that made sense. And did we answer all the questions?